And Hess's law just tells us that if we have 2 or 3 or any number of chemical reactions that we can add together in order to get the chemical equation that we're actually interested in, we can figure out the change in enthalpy of that reaction that we're interested in just by adding together all of the other enthalpies of reaction for every other reaction that we had to add together in order to get there. So let's take a look at what we're talking about here. So when I just showed you that example graphically, I'm just writing it out more like an equation here, because the nice thing about Hess's law is it allows you to think about chemical reactions kind of as if they're just algebraic expressions. So we can just add all of these different expressions together, and if we're thinking about algebra, we can just think about crossing things out that are in the reactants versus in the products. So if we do this, what we end up getting is the reaction that we're interested in, the oxidation of glucose to form carbon dioxide and water. So let's look pretty carefully at exactly the fact that these all cancel out to give us the reaction I say we get. So for example, we can think about the oxygen molecules. We can cancel out 6 here and 6 here as long as we multiply this whole reaction by 6. Again, we can get rid of those last 3 oxygen molecules there. Similarly, we can cross out our 6 hydrogens from the products with 6 molecular hydrogens from the reactants. And then the last thing we can cancel out are our carbon atoms. We have 6 in the products, and we have 6 in the reactants here. So you'll see that the only things that are not canceled out is what's left in our bottom reaction. So we can go ahead and just add up all of these different reaction enthalpies. In the first case, what we're going to have is an enthalpy of 1260, and that's in kilojoules per mole of oxygen, or excuse me, per mole of glucose. And the reason that this is positive is because it's essentially the reverse reaction of the change in enthalpy of formation. So it's going to be a positive number there. We add to that the enthalpy for this reaction here, which is negative 393.5. But we need to remember to multiply that by 6 because we're actually adding together 6 of those individual reactions. And lastly, we also add together 6 of this final reaction here, which has an enthalpy change of negative 285.8. So if we go ahead and just add up all of our individual enthalpy changes, what we're going to end up with for our entire reaction here is a change in enthalpy of negative 2816, and that's kilojoules per mole of glucose.